dear students. Today's lesson is about momentum. It's all about collision. And everyone knows that there is a famous apparatus, we call it Newton's cradle. It demonstrates the principle of conservation of momentum. There are maybe 8 or 9 or 10 balls. They are hanging with strings, and you just hold the first ball and let it hit the second ball. The first ball will stop, but it will transfer the momentum to the second ball, which is consecutively hitting the third ball, and the second will stop, but the third will move until we find the last ball is moving. Then it starts to hit the one before the last, and so on. This is it shows very clearly conservation of momentum. So now we have here momentum is simply mass into velocity. Momentum is a vector quantity because mass is a scalar quantity. Mass is a scalar quantity. It's measured in kilograms. And you multiply it by velocity, which is a vector quantity measured in meters per second. So the momentum consecutively will be a vector quantity. It will be measured in Newton second. Of course, you'll ask me, why don't you say it's measured in kilogram meter per second? Because simply it has two rules. As you can see the two triangles in front of you. Momentum equals m times mass times velocity. Momentum equals mv. Momentum equals mv. Momentum equals mv. Momentum equals mv. What about impulse? Impulse is the change in momentum. So it should be having the same units of measuring, which is kilogram meters per second or something else. Let's see. Change in momentum means mv minus mu. mv minus mu. Impulse mv minus mu. Impulse mv minus mu. So impulse is the final momentum minus the initial momentum, but it has another rule. Depends on the givens in the question. If you are given the force by pushing this object to let it collide with another object and the time of action, so if you are multiplying force into time, so you are multiplying Newton by second. Impulse is having the same units of measuring momentum. How do we measure impulse? Impulse equals Ft. Impulse equals Ft. Impulse equals Ft. Impulse equals Ft. Force is measured in newtons and time is measured in second. So impulse is measured in Newton second. And momentum, because it is having the same units as measuring impulse, it depends. Here it's mass, which is measured in kilograms, multiplied by velocity, which is measured in meter per second. So momentum will be measured in kilogram meter per second. We can just say Newton second or kilogram meter per second, it's the same. Now let's have some examples on this issue. The first example. Find the magnitude of the momentum of the cricket ball of mass 400 grams moving at 18 meters per second. If the mass is 400 grams, it means it should be converted. Why? Because remember, we are dealing with SI units. What are the SI units? It stands for Système International. It's a French word, which is the International System Units. It is the MKS units. M means meter, K means kilogram, and S means seconds. So this is because we have to deal with force measured in Newton. So to deal with Newton, so you have to convert anything that needs conversion, like this question. The mass is given in grams, 400 grams. You should divide it by 1000. Big to small, multiply, small to big, divided by. You should divide by 1000, so mass will be given in kilograms now, 0.4 kilogram. Velocity is no conversion. Velocity is 18 meters per second. momentum equals mv. Momentum equals mv. So just multiply mass, which is 0.4, by velocity, which is 18, and you'll get the answer 7.2. 7.2 what? 7.2 Newton second. You can write it as 7.2 kilograms meter per second. This is correct, and this is also correct. The next question. A lorry of mass 5 tons moving at 0.3 meter per second. If the mass is 5 tons, so it needs to be converted. Okay, let's go. Mass is 5 tons, you multiply it by 1000. Big to small, multiply small to big, divided by. And velocity is 0.3 meters per second, no convert. Now let's calculate. The mass, the momentum equals mv. So you will multiply the mass, which is 5,000 kilograms, by velocity, which is 0.3, and you will get the answer in kilogram meter per second. It will be 1,500 kilograms meter per second, or Newton second. Next, here we have impulse. If a constant force acts for time t, then we define the impulse for the force by Ft. Impulse equals Ft. Impulse equals Ft. Say it, impulse equals Ft. And impulse is also change in momentum. Let's read example 2. A body of mass 2 kilograms is initially at rest on a smooth horizontal plane. And let's write this information. A body of mass 2 kilograms, so no need to convert. Initially at rest means initial velocity is 0. On a smooth horizontal plane, thank God, no friction. A horizontal force of magnitude 4.5 Newton, F is 4.5 Newton, acts on the body for 6 seconds, so time is 6 seconds. So now you have to use impulse equals Ft. Find the magnitude of the impulse given the body by the force, given to the body by the force. Impulse equals Ft, force, multiply by time. The force is 4.5 Newtons. You multiply it by 6 seconds, and the answer will be 27. So impulse is 27 Newton second. Very nice. Second question. Find the final speed of the body. The final speed of the body comes from the first rule, which is impulse is the change of momentum. Impulse equals final momentum minus initial momentum, mv minus mu. So I'll continue here. Impulse, we got it before, which is 27, equals the mass, which is 2, into final velocity, minus the same mass into the initial velocity, which is 0. It means 27 equals 2v, divide both sides by 2, v equals 13.5 meters per second. Of course, you'll ask me, Miss, why don't we take m as a highest common factor? For such cases like this one, keep m without taking it as a highest common factor, because we are dealing with each term individually. So nice and easy. Let's continue. A ball of mass 0.2 kilograms hits a vertical wall. Here is the ball of mass 0.2 kilograms hits a vertical wall at right angles with speed 3.5 meters per second. This is the initial speed of the ball, because when it hits the ball, it will rebound. Here is the vertical wall, and here is the ball. It hits the wall at right angles and then rebound with a different speed. Okay? Initial speed is not like final speed after rebounding. The ball rebounds with speed 2.5 meters per second. So this is V. V means final velocity. The ball rebounds with speed 2.5 meters per second. Find the magnitude of the impulse exerted on the wall by the ball. I need to concentrate on the expression. Find the impulse exerted on the wall by the ball. Because the ball is the object which did this impulse, so we will consider the mass of the ball and the velocities of the ball. Let's go. Now, first of all, we have to consider a positive direction of impulse. When the ball hits the wall like that, here is the wall and here is the ball, it hits it like that. You can see me in the video like that. Here's the wall and the ball coming from this direction. So there is an impulse like this direction, okay? Impulse is the opposite direction of the initial velocity. Impulse direction is the opposite direction of the initial velocity. Initial velocity is going to the wall and the impulse is in this direction. First of all, you have to assume the impulse sign as positive to this direction. Take care, I'll say it once more. Assume the impulse sign. Draw an arrow and show it to the examiner. He must know how did you think about signs. This means that initial velocity u will be negative 3.5 because this arrow is in opposite direction, and final velocity v will be positive 2.5 because it is in the same direction of the impulse. Now I equals mv minus mu, mv minus mu. Mass is 0.2 multiplied by final velocity, which is 2.5. Minus mu, the same mass, 0.2. In this case, you can take m as a common factor, no problem. 0.2 multiplied by the initial velocity, which is negative 3.5 in brackets. When you calculate it, you will get impulse as 1.2. Take care because minus will be plus. So now, when you calculate it, it will be 1.2 Newton second. Now we're done about examples and we can take a quiz from the exercise. Question 1, time for quiz. Question 1, a ball of mass 0.5 kilograms. I love to draw it, and drawing is essential. Is at rest when it is struck by a bat and receives an impulse of 15 Newton second. Find the speed immediately after it is struck. In this question, drawing is not essential, but when we take collision, you will find drawing is very essential and you will gain marks on it. So this ball of mass, 0.5 kilograms, is at rest. It means initial velocity is 0. When it is struck by a bat and receives an impulse of 15 Newton seconds, find the speed immediately after it is struck. So we will use the rule which is I equals mv minus mu. mv minus mu. I is 15 and mv, it is 0.5, no conversion, it's in kilograms, thank God, into v, which we don't know, minus m, the same m, which is 0.5, into u, which is 0, and then it is 15 equals 0.5 v. If you divide both sides by half, means you multiply by 2, so the velocity will be 30 meters per second. Da-da-da. Next quiz. A ball of mass 0.3 kilograms is moving along a horizontal surface, hits a fixed vertical wall. Here is the ball, and here is the wall. Let's write all the information. The mass of the ball is 0.3 kilograms. Moving along a horizontal surface, hits a fixed vertical wall at right angles. So here is the initial speed with speed 3.5 meters per second. The ball rebounds. Final velocity. The ball rebounds at right angles to the wall. He didn't mention the final velocity. Given that the magnitude of the speed, given that the magnitude of the impulse exerted on the ball by the wall is 1.8 Newton second. Of course, this is the impulse. And this is the positive direction of it. The impulse is 1.8 Newton second. Of course, he'll ask me about V. Find the speed of the ball. See? Find the speed of the ball just after it rebounds. So now we have the same rule, which is I equals mv minus mu. mv minus mu. I is how much? It's 1.8. Remember, we have to consider signs. This arrow going to the right, this arrow is going to the left. So the velocity here is negative 3.5. Remember, you will assume the direction of the impulse. And consecutively, all the same directions are positive. So velocity of rebounding is in the same direction of impulse, so it will be positive. And 1.8 equals m, which is 0.3 times v, which we don't know, minus m, which is the same 0.3 times initial velocity, which is negative 3.5, minus equals plus 0.3 times 3.5 equals 1.8 is equal to 0.3 v plus 1.05. Cross the bridge and change the sign. 1.8 minus answer equals. So here is 0.3 v is equal to 0.75. We divide both sides by 0.3 and the velocity after rebounding will be 2.5 meters per second. And we'll go forward to take more about collision. See you in the next video. Bye bye.